For the question number one, they ask they want to purify the antibiotic from the major contaminant. So they want to know after they purify, what is the purity level of this antibiotic. So they state the partition coefficient of the antibiotic and the coefficient of partition coefficient of contaminant as well. And they also tell that the feed raffinate extract and solvent phase flow rate are equal. So the question, they want to know the purity level after they extract the antibiotic from the contaminant. And they also ask like, is it good to do this antibiotic for the counter current of sweet steak? So like the solution, since we know that the feed and the feed raffinate extract rate are equal, so we can write actually some lecture or from Ajahn, it's actually egg and L. This I found from the internet. They denote as F and S. So F is actually flow rate of feed or raffinate phase, S or L flow rate of extract phase, and it actually the steak that they are going to extract. So since they the feed and extract are equal, we actually can write the fraction of this gonna be equal 1, and the steak gonna equal 3 because we gonna do 3 steak. So we consider for the antibiotic, we know that for the antibiotic, the partition coefficient equal thick. So we want to know E. I forgot then. What is it? Actually fraction or something? I forgot. Sorry. So E actually equal to K equal S over L or A over L. It's actually the same. So 8 over L or S over L, it actually only 1. So 1 multiplied by 6, it's gonna be 6. And this one is the formula from the feed something. It denotes as egg, feed, F, and raffinate this. So it say it's n time or something, but so we do only 3 times, and so we gonna divide. We can say divide by it FA. So it's gonna be only this, and we know E already, so we substitute, we got this value. And so we also consider on the contaminant as well. When the partition coefficient of contaminant is equal 1, it's actually the special case. So if we use this equation, it's gonna be infinity or something. So it's not like that. So it's gonna be some special case. So I don't know, they might do the limit or something, but I only saw the full formula from this, so I just substitute it in. It actually is do like the same above, like 1 and is the number of steak, and plus 1, it can be 0.25. So in order to calculate the purity of the antibiotic, need to follow this rule or formula or something. And we know that the feed ratio of feed gonna be I don't know, feed as A antibiotic or something, and and contaminants gonna be one. It fit like from there, from this one, but just assuming that the feed contain only these two antibiotic and component, antibiotic and tocol, is something 331. So we know that it 3 over 1. So we cannot say HFA over HFB. They call like 3-1. So in order to calculate the purity, so we need to know all these parameter. So HFA gonna be equal 3. Actually, it's gonna be like HFA gonna be like 3 FB, 3 FB, but actually FB only one. So you know this as well. And this one actually from the above H and B equal to this when we H and B equal to 0.25 multiplied by HFB. So HFB only one, and H and A gonna be the same from this number multiplied by this HFA. So we get this value, so we can calculate the purity level of this. It only like 0.79 or can say 0.80 or 80% when we feed 3 or 3/1, like fraction over 1, feed like 70% of the feed, we only get like 80% purity. So this can be conclude that it's not effective, or it's not good to do this extraction, even though it's a 3-stage already. It's not good. For the question number 2, we want to, where the question? We want to know the volume ratio of top and the bottom face of this extraction. Yes, the extraction occurs two-phase polyethylene glycol extraction. I just draw to like a little bit more understand. This actually from the equation that in the lecture we can y in the recovery y AU, actually A denote like the substance A that we recover from the extraction. So like it the recovery in the percentage, we can see how much we can recover in the percentage of this extraction. It related to the volume of the upper and upper and lower phase of the to extract to solvent and contaminant, or something that we want to extract that contaminate something, and we want to know this ratio volume of upper and lower phase, and we are going to derive this equation. So this we want VU over VL only. So we going to like to separate it from the equation. So we do a little bit of mathematical equation, and so I got this VU over VL equals to this the recovery over partition divided by this term. And so we already know that we want the maximum, we want to achieve 80% of recovery, and we already know the enzyme partition coefficient is 3.5. So we are going to substitute into the equation that we derive. So we got 1.1343. This is the fraction of the upper volume and the lower volume. So about the question, they want to know the concentration factor when recovery is 80% and the volume of the bottom phase is like 100 liters. So we know that when we recover 80% and the VL, the volume of the lower phase 100 liters. So for this I still not clear like whether it the product prefer lower phase or the upper phase, but since the question provided it the phase is 100 liter, I'm going to say that it prefer the lower phase. So this is the formula or the term that we are going to the concentration factor denoted as delta C over concentration of lower phase, or when the product is prefer the lower phase over the concentration of the original term and concentration of the initial condition. And we already know that at the initial condition CaO equal to 3.2 unit of enzyme over milliliter, but we don't know concentration of the lower phase. But actually we know the term the recovery of the lower phase equals to volume of the lower phase multiplied by the concentration of the lower phase and original volume or initial volume, and also multiplied by the concentration of the original state. So we know everything. We want to recover 0.80%, it's 0.8, and V0 equal 150 liter, and we know the initial concentration of enzyme 3.2 and divided by VL the lower phase, and we're going to get the concentration of the lower phase when we recovery at 80%, it equal to 3.84. And we can calculate the concentration factor. We already calculate the concentration of lower phase, and we know the concentration of the original state, and we can calculate the concentration factor equal to 1.2. That's all on my presentation. Thank you. I need your comment. I know something wrong with this. I'm not really sure.
Thank you for the presentation. Okay, I will check the homework and then, sorry, I will check this later. Okay.
So for now, you don't have any comment for this, Ajahn?
Yeah. Thank you for that. I will check this later. Okay.
Okay, thank you so much, Ajahn.